Hello guys, welcome back. So here we've designed a quick class test based on the topics that we worked with from the previous videos. So on the previous videos we spoke about the fancy concepts, whereby we spoke about corresponding angles, co-interior angles, alternating angles, vertically opposite angles, and adjacent angles on a straight line. So if you're not yet familiar with those concepts, please go check the previous videos. They'll be on a playlist for grade 9 term 3. So now with this one, this video is meant for us to solve, using those concepts, some questions that once appeared on previous question papers and see how far we can go with it. So we'll just go straight to it. Let's start with this one here. So these questions that I'm about to do, they are worth a whopping 37 marks. So if you are able to answer them, in any case where we are starting, try to make sure that you pause the video, you solve the questions by yourself, and then after that, that's when you'll continue to see how we found the answers and see if they match with your answers. However, we do know that this is geometry of straight lines. Obviously, there are multiple ways to get to the correct answer. So don't beat yourself if you do find out that we didn't get the answer in the same way that you did. But the most important thing here is to make sure that you understand the concept. As I am providing the answers, I'll also try to make sure that I tap on the alternative methods. But sometimes this topic is so broad that I might not even touch on all the solutions that are possible to answer one question. So here, to do yourself some justice, please try to pause the video and see if you can solve these questions. Only 5 questions for 10 marks. Remember, we said whenever you are solving questions that are worth 10 marks, it doesn't mean that we need 10 steps from you. It means that with all the questions that you are solving at this point, you should be able to solve them in less than 10 minutes, at most 10 minutes. Okay, let's get to the solutions. So the first question says calculate with resonance angle L1. So on your left side there you have a diagram. I'm going to get a little bit messy on this diagram because I don't think I'll use it again as much as we did on the previous videos. So angle L1, let me use a different color here. Here is L1 right there. So we want to see if, according to this diagram, can we be able to use those fancy concepts to solve for L1? We do realize that L1 is situated in a place whereby we can see a Z formation. So firstly, I see that this line is parallel to this one. So ML is parallel to JK. I also see that JN is parallel to OL, right? And those parallel lines are also parallel to MP there, okay? That's what we are given. What else? We do see that we have three given angles. We have 120 degrees there by K, we have the 60 degrees by J, we have the 30 degrees by L there. So we'll try to see if we can use the given angles to solve for the unknown angles. So quick. Back to this one. Here I do see L1, and not only that, I do realize that I have a sort of a Z formation right there. And this Z formation uses parallel line JN being parallel to OL. So that can work for me, as I see that angle L1 is on the armpit of this Z formation, and the 60 degrees is also on the armpit of that Z formation. So we can use that. That's alternating angles. So I'll just say here that L1 is equals to 60 degrees because the angles are alternating. Now let me write that one down. Angle L1, you see the angle cap must be there. It's equals to 60 degrees. And then I provide my reason. Alternating angles. Then I should always mention my parallel lines. Here I'm going to say JN is parallel to OL. Question number 1 already in the bag. Number 2, 1.2, let's use the proper numbering system. This is 1.1 and this is 1.2. So 1.1 done with. Now we need to solve for 1.2. 1.2, they need us to find J1. So looking at J1, let me use a different color right here. Let's use pink this time. Here is J1. I also see that this J1, it forms a Z formation. Here is that Z formation right there. And this line is parallel to that line. So as long as I see a Z formation and I see parallel lines, then I have alternating angles on the armpits of the Z formation. Now let's use that. I know that J1 is equals to this 30 degrees there. Let's write that down. J1 is equals to 30 degrees. Reason alternating angles. And then I'm going to say JK is parallel to ML. Just like that. Question 1.2 already in the bag too. Then the next one, we are supposed to find M2. So now when we are looking at M2, M2 might be tricky for some people. But then if you already know how you are supposed to use your concepts, then this shouldn't give you a problem. When we are looking at this line right there, we realize that we have a Z there. And this Z, we know that this line is parallel to that line because it was given to us. Therefore, which means right there and this whole thing, these are alternating angles. Let's try to use that now. Let's try to use that. Let's use a smaller marker. We are saying we know that angle M2 must be equal to the whole of angle L. Now, what is angle L composed of? It's composed of this 30 degrees and that L1. Together they make the whole of angle L. So let me write that one down. I'm saying here for 1.3, we are saying angle L is equals to angle M2. And our reason for that is because we saw a Z formation. A Z formation is associated with alternating angles. Which parallel lines are they using? We know that OL is parallel to MP. Right there. But then what makes up angle L? Angle L is made up of two angles. First, we have the 30 degree angle. Right? Here's the 30 degree. We also have angle L1, but we already found L1. On question 1.1, we said on question 1.1, we said L1 is equals to 60 degrees. So here I'm going to say plus 60 degrees is equals to angle M2. Right? Oh, we don't need to provide a reason again. We already gave the reason. So we are saying this 30 degrees and this 60 degrees is equals to the whole of angle L. And then we said the whole of angle L is equals to M2. Now, to simplify that, we are going to say, what is 30 degrees plus 60 degrees? That is 90 degrees. So I'm going to say 90 degrees is equals to angle M2. And then we go to M2 there. On your diagram, where you see M2, you're going to annotate that this angle is 90 degrees because that's what we just found now. So 90 degrees for this angle. Right. So we are done with 1.3. Now we move on to the next one. 1.3 out. Then 1.4, they said you must find angle K1. So here is angle K1 there. I'm sure you can already see where this is going. So for K1, next to it, we have the 120 degrees. Now, What does that mean? It means we have adjacent angles. Adjacent angles where? We have adjacent angles on a straight line. So here for 1.4, let's say that 1.4, I know that if I add angle K1 with the 120 degrees, sorry, let's fix that. Let's do it again. We are saying, I know that for 1.4, if I add angle K1 with the 120 degrees, I must get 180 degrees. Reason for that? Because these are adjacent angles on a straight line. Easy as that. And then I solve for K1. So I'm going to say K1 is equals to 180 degrees minus 120 degrees. And then we know that that is 60 degrees. Right. Great. And then what else? 1.5. Let's see what do they want with 1.5. For now, we are done with 1.4. So for 1.5, they are saying let's find M1. So you do realize that if we found K1 just now, the examiner was leading us to be able to find M1. So since we found K1, let me highlight that so that we can all see it. So since we found K1 right there, K1, it forms a Z formation with M1. And we have parallel lines for that Z. Here is the parallel line there, and here's the parallel line there. So that shouldn't be a problem. So I can say here, I actually see my Z formation forming right there. And since this is a Z formation, I know that this line is parallel to that line, and we are not making this up. It's here on the diagram, and then on the armpit there's an angle, on the armpit there's an angle. I already found K1. We said K1 is how much? We just found now that K1 is 60 degrees. Therefore it means M1 is going to be how much? M1 is also going to be 60 degrees. Thank you. So let's quickly write that down. So it's one thing to realize the answer, to see it, and then it's another thing to be able to write down your answer. So this is geometry of straight lines. Some people, they do know the answer, but they fail to know how to write it down. So let's quickly write that one. We are saying K1 is equals to M1, okay? 1.5. 1.5. We are saying angle K1 is equals to angle M1. And then they are all equals to how much? 60 degrees, because we just found K1 here to be 60 degrees. And what is the reason they are equal? Well, they formed a Z formation. Therefore, it means they are alternating angles. If they are alternating angles, which parallel lines are they using? I see that this angle right there, this angle, it's using the line JK. So I'm going to write that one down. I have JK is parallel to which line? I know that this angle, this one, the M2, it's on the line ML. So I'm going to write it's parallel to ML. So there is ML there. Easy as that. Now to the next question. Quick. Remember, when you are on a test, you want to write the answers you know, and then you move on, just like that. So here, fortunately, we knew all the answers, applying all the concepts we learned from the previous videos. Then the next one here. Here's another diagram for 4 marks, which means this one should be a walk in the park. It says use the figure and determine with reasons the value of x. So here on this diagram, first you must be able to analyze your diagram, guys. Don't be afraid to take your time to analyze the diagram, because once you understand the diagram, it won't take you too long to get to the answer. So I can see that this is x, and this angle is not 20 degrees. You call the whole thing, this angle is x plus 20 degrees. So an unknown with a known value. And then this angle is 3x. So there are things that are given and there are things that are not given. You used what is given to find what is unknown and given. So here, there are things that we know, and there are things that we don't know at all. Like, look at this angle right here. We don't know what is this angle. And there is no even variable that represents this angle. So which means these angles that you see here without variables, we are not supposed to use these angles according to the examiner. Same thing applies here. Here we have angles that we don't know. We don't even have variables for them. So we are not supposed to use this angle. Again, there are people who might even say, well, 3x corresponds with this angle here, and then I can say adjacent angles on a straight line right there and find the value. However, you cannot say that because the angle you are referring to, this one, we don't know what it is. The examiner never gave us this angle. Therefore, we must avoid using that angle. What we must use is what we know. So with that being said, which angles do we know? Oh, sorry, I'm removing these things. The angle that we have, it's P1 here. So this P is not an angle. It's a point of intersection right there. So I have P1, I have X plus 20, and I have 3X. So one thing I do realize is that if ever I can somehow form a shape here in this sense, I realize that I have a Z formation in this manner. Quick. And I know that this line is parallel to that line. Here's an armpit, here's an armpit. Right. What type of an angle relationship? These are alternating angles. I use that. I'm going to say 3x is equals to P1. Let's write that down. So I'm saying 3x is equals to angle P1. What is the reason for that? Alternating angles. Which parallel lines are they using? So this angle, it's on CD. So I'll write CD is parallel to, and this angle, this one, it's on the line AB. You call the whole line. So this is AB. I know there are people who will say, well, you can also call the line PB. Trust me, avoid that. Just call the whole line in terms of parallel lines. So we found that one out. So which means here now, I can just come and say the angle here is 3x. All right? Yeah. So, and then after that, we can come to this conclusion that this angle X and the angle X plus 20 and the angle 3X, they are on the same straight line, which is this one, right? And we also see that these angles are next to each other, so they are adjacent. So now I'm going to write that one down too. I'm going to say, if I add this angle, X, and I add another angle, which is X plus 20 degrees, and then I add this last angle, which is 3X, I must be able to get 180 degrees. Reason for that, adjacent angles on a straight line. I hope you still remember this reason and how to write it down. There are people who would say the reason here it's supplementary angles. Trust me, this is not supplementary angles. You are supposed to say adjacent angles on a straight line. It's best you say it that way, regardless of who's teaching you. So here, then we have simple algebra, which we have X, and then we have 3X. What are those things? If your answer was like terms, you got it right. So here we know that X and 3X, they give us 5X. And then we have this 20 degrees right there. So it's going to be plus 20 degrees. This is equals to 180 degrees. After that, we are going to transpose. Of course, there are people who still cannot say this word transpose. So subtract 20 degrees on the other side. And then you are left with 5x is equals to 160 degrees. And then from there, what are you supposed to do? The multiplicative inverse. You divide by 5 here. So this divides into that. And then you have this dividing into that. Therefore, in this case, you're going to have x. And trust me, you don't want to waste your time on these things. When you're in an exam, you pull out this baby here. Right there. You pull out this baby. You don't waste your time. You don't open any room for errors. Just tap it on like that. This is your machine, guys. You are never going to be arrested for using this. There you go. They're telling us that this is, wait, how much was that? 32 degrees. Easy as that. X is 32 degrees. That's all they wanted. Stop being afraid of using this thing, guys. I don't understand the concept of a person getting values wrong when they have a calculator. Sometimes, I don't know, you're trying to flex your muscle in an exam, but nobody's watching you. Just use the calculator and get the answer right and move on. So, next one. Here is the what looks like a big boss for like 13 marks. So here, question 3, it says in the diagram below, well, here's the diagram that they're talking about. It says in the diagram below, here's the diagram. You have PS, here's PS, it's parallel to TU. It's parallel to TU, here's TU. And they're saying TU is parallel to QR. So here is TU being parallel to QR. We can see that. And they're saying PQ is parallel to SR. You see, they're calling the whole line. As I told you, mention the whole line for parallel lines. So PQ is parallel to SR. You call the whole line. And then they are saying angle T1 is equals to 75 degrees. This is not 175. This is T1, 75 degrees. And then you have U2, 35 degrees. So here's U2, same U2 is 35 degrees. And they are saying calculate with the reasons. Of course, this is geometry of straight lines. You have to calculate with the reasons, the size of the following angles. So in that case, let's see what we can do. Angle P1. P1, 3.1. Let me just write P1 there. I'm sure it's easy to find. 2 marks. What is that? They're saying we should spend 2 minutes. I bet we can spend less than 2 minutes. Where is P1? So I'll use a different color pen here. Let's do that. Here is angle P1. Angle P1, find the value of that. Look at it. It's like resting there in front of us. This is equals to that. Why? Because there's a Z formation there in case some of you didn't see it. So here's the Z formation and here are the parallel lines. So this angle alternates with that, right? I hope you are all catching up with me now. So P1 is equals to 35 degrees. I told you, you don't even need 2 minutes for this one. So P1 is equals to 35 degrees. Oh, sorry. You have to mention which 35 degrees. So P1 is equals to U2. And how much is U2? U2 is 35 degrees. Then you provide a reason. Because these angles are alternating angles and they are using the parallel line PS and TU. Even if you said SP, UT, it's fine. The order in which the alphabets follow one another, it really does not matter. And then 3.2. 3.2, they said you must find angle P2 for 3 marks. Well, if they said for 3 marks, then I bet there is some calculation in it. Where is P2? Let's find it quick. Where's my mouse? Oh, there we go. P2. So here is P2. They need us to find the value of P2. Nice one. But then we can see already that PTU is a triangle. That's one thing for sure. Or we can use co-interior angles because for now in this channel we haven't covered triangles, right? Yeah. So what I see is that here I have a U. You see how we are spoiled with options? We always are. This is maths, guys. You always have more than one way to solve a problem. So here we have a C formation from the Fang's rule. Obviously, we know that this is co-interior angles. So which means this whole angle must be equal. When we add it up with this whole angle, we must get 180 degrees because this line is parallel to that line and is a U shape. So quick, let's get that through. Yeah, erase that. So let's put it in writing. I'm saying P2 plus P1. So we are talking about the whole of angle P. If I add P2 and the P1 there, and the 75 degrees, I must get 180 degrees. So plus T1 plus angle T1, I must get 180 degrees. Why? Because they form a C formation. What is C formation? Co-interior angles. These co-interior angles, which lines are they using? The line PS being parallel to the line TU. Easy as that. Then substitution, of course. How much is P2? We are looking for that, so we don't know. P2 plus how much is P1? We know that P1 is 35 degrees because we found it in 3.1. Plus how much is T1? We were told that T1 is 75 degrees. All that is equals to 180 degrees. So, and then we have this one. Now, let me tell you what someone is going to do here. Someone somewhere is going to try to add that 35 and 75 by his head, trying to flex in an exam and then get the whole thing wrong for just doing things he doesn't have to do. Nobody's watching you in an exam. Just do this. You see that? On my own video, I'm not ashamed to use a calculator. So why would you, when you are alone in an exam? Why would you be ashamed? So there we got our answer, guys. And then this is equals to 180 degrees. And then we solve for P2. Angle P2 is equals to 180 degrees minus 110 degrees. Now, I bet most of you already know this answer here, but this is me, the average Joe, who doesn't want to flex in an exam. I just go there just to make sure I don't make a mistake. You see that? 70 degrees. Easy as that. So quick. I found out that this is 70 degrees. So we found P2, that was 3.2. Now we have to find 3.3, which is T2. So let's see that. Let's see that. Quickly see that. Sorry, I'm making errors here. So 3.3, they said we must find T2. Let's highlight T2 there. Let's use a different color maybe. So here is T2. Now, when we are looking at T2, I mean, come on. We are spoiled with options here. Already we have the whole of angle P. I'm sure you can already see where I'm going with this. We have the whole of angle P. And then we have just next to us, we have this 75 degrees. And I'm sure you all can see what does this mean, right? So let's choose the easier option, of course. As a math student, you must always opt for an easier option. So 3.3. To find T2, I'm going to say T2 is equal to, in case you missed it, because I know there is someone who didn't pause this video to solve it by himself or herself. T2, for some reason, it forms an F formation like that. So there's the F formation. And I know that this line is parallel to that line. And on the F formation, here's the first armpit and here's the second armpit. So the whole of angle P must be equal to T2. Right. And I have the whole of angle P. Remember that. So here, I'm going to say T2 is equals to the whole of angle P. How much is angle P? Remember, I found angle P. I know that angle P is made of P1, which is 35 degrees. I know that angle P is made of P2, which is 70 degrees, right? So I'm saying this is equals to P1 plus P2. How much is P1? Right there, right there. P1 is 35 degrees. How much is P2? P2 right there, 70 degrees. Again, I'm saying, I know that there is someone on a test who will try to flex his memory right here. And I'm telling you, there's no shame. Just press the calculator and get your answer without any errors. This is equals to 105 degrees. Now, back to the reasoning. Why was angle T2 equal to the whole of angle P? Because it formed an F formation. And F formation means what? It means we are working with corresponding angles. And that corresponding angles, those corresponding angles, they used which parallel lines? Well, those corresponding angles, they used PS and TU right there. So I'm going to say PS. Here we go. Where is it? I'm going to say PS is parallel to TU. Close that. Then 3.4. Guys, I'm sure you can all see how much we are flowing on this thing. An easy 13 marks right there. 3.4, they are saying we must find U1. Now, let's see U1. Now, U1 should be a walk in the park. I'm sure you can all see that. Those of you who have solved this question before clicking the play button, I'm proud of you, and I'm sure you've already found this one. So we can see that U1 is equals to P2, right? By what reason? We can see the Z formation here. Come on. There we go. We know that this is parallel to that, right? So I'm going to say U1 is equals to P2. Let's put that in writing. U1 is equals to P2. Angle U1 is equals to angle P2. How much is angle P2? Let's go back. Did we find P2 at some point? P2 maybe? P2, we found it at 3.2. And then we said it's 70 degrees. Oh, something happened here. I don't know what. So we said it's 70 degrees. Right? So let's say that here. We are saying U1 is equals to angle P2, and then angle P2 is 70 degrees. Why? Because they form a Z formation. So these are alternating angles. And then they are using which parallel lines? We know that they are using the line PQ. Remember to call the whole line. So I'm going to say PQ. So here I have PQ is parallel to, it's parallel to which side? SR. So here is SR. The Z formation uses SR. So I'll say SR here. Then 3.5. What does 3.5 want? Let's see that. We did this. We got 3 marks there. We got 2 marks. We got 2 marks. Now we are here on 3.5 where they want U3. I don't think I even have to say this one because it's so obvious. We just found U1 right now, and U1 it's 70 degrees. And then, you are looking at U1, you are looking at U2, you are looking at U3 next to each other on the same straight line. It can only be adjacent angles on a straight line. Or there is someone who sees it otherwise, someone who did this problem before pressing play on the video. And then that someone was able to see that T2, for some reason, T2, it somehow alternates with U1 and U2, right? And then they found their answer too. So we are spoiled with options again. So I'm just going to say U1 plus U2 plus U3. Those angles are next to each other, adjacent angles on a straight line, right? So let's put that into writing. We are saying angle U1 plus angle U2 plus angle U3, that is equals to 180 degrees. What is the reason for that? These are adjacent angles on a straight line. For some reason today my reason was very long. Okay, how much is u1? How much is u1? Let's see. u1 is 70, u2 is 35. I'll substitute right here. So we are saying u1 is 70, and then u2 is 35. u2 is 35 degrees plus u3, this is equals to 180 degrees. You know what, I actually need space here, so all the things that we wrote here which we no longer need, into the bin, like this ones. We are done with you guys, right? Of course, let's provide some space for more useful things. So let me move this one above so that we can work with it. This thing of scrolling up and down, it's not ideal. There we go. Here, right there. So we are saying u1, here is u1 plus u2 plus u3 is equals to 180 degrees. And then we said u1 is 70 degrees, u2 is 35 degrees, and we are looking for u3. So quickly, let's do that. So u1, u2, 70, 35. Well, we all know this is how much. We are not even going to say it. But for the sake of that one person who is not going to pull out a calculator in the exam to check the answer here, I'm going to do it for them so that they don't feel ashamed, of course. So we are saying when we add these two, we get 105 degrees plus u3, and this is equals to 180 degrees. After that, then we solve simple algebraic problem. So here we have u3, angle u3 is equals to 180 degrees minus 105 degrees. And we know that, wait for it. Of course, you know what we are going to do here. We are going to say 180 degrees without any shame minus 105 degrees. That gives us 75 degrees. So here we go, 75 degrees right there. Boom. So u3 is 75 degrees. Let's write that on the diagram. On the diagram, we can just say this is 75 degrees, right? Don't be scared to fill up your diagram with writings, guys. We are not going to penalize you for that. It's your question paper. You are free to do whatever you want to do with it. Just don't tear it apart. You can write anything on it. You can calculate however you need to. So we are done with u3. Now the last question for this 13 marks. So we are done with this one. We are left with angle S. Now look at angle S right there. I mean, come on. The answer is just staring you at the face. There's an easier way to do it, and there's a difficult way. It all depends on you. I mean, we are spoiled with options here. Firstly, we have this one. Look at here. We have an F formation right there with parallel lines staring at us right there, which means this angle is equal to that angle. So we already know that angle S is 75 degrees without sweating anyhow. Or there might be someone who paused this video to try to solve this question on their own, and they might have found a U shape facing downwards like that. And I mean, here we have these parallel lines, and then we know that if we add this angle with that angle, we must get 180 degrees, and then we solve that using co-interior angles to find the value. And the value we must find is 75 degrees. Or there is a person who might have seen this C formation like that. And then we have these parallel lines again staring at us in the face. And we know that if we add this angle with this one, we must get 180 degrees because these are co-interior angles. Easy as that. But of course, because we are mathematicians, we'll choose the easier way out. And what is the easier way out? Is to choose something that has fewer steps. Like an F formation maybe, whereby we have an angle on this armpit and we are trying to equate it to that angle there. So there we are going to say, for 3.6, looking for angle S, we are going to say angle S is equals to angle U3. And how much is angle U3? Is 75 degrees. Why are these angles equal? The relationship between angle S and angle U3, we know that they form an F formation. Therefore, they are corresponding angles. And if they are corresponding angles, which parallel lines are they using? They are using PS being parallel to TU right there. So that's an easy 13 marks for grabs, guys. I'm sure you all got it. And now let's move to the next segment of our question paper here. So where is it? Quickly scroll down. So here you go, for 10 marks, an easy 10 marks. I'm sure you can all see that. But then there are people who usually see a diagram at first and be like, what is this? This is difficult. You never taught us this one. Yeah, I know that. You know yourselves. So for 10 marks, they are saying determine the values of the unknowns and give reasons for your statements. Give reasons for your statements. Of course, this is geometry. You have to give reasons for your statements. This is the question here. Make sure you read the question carefully before answering anything else. So here, there are some things we have to highlight first. You must understand that there are labels that are points of intersection, or the label is the end point of your line segment. And there are variables that represent angles. So whenever you see a capital letter like that, either this is labeling a line segment or it's a point of intersection. Sorry for that. So these capital letters, these are points of intersection, or they are meant to label a line segment. And then the other variables that you see there, those are the variables, those are the unknowns, because they are small letters. We usually represent angles with small letters. So the rule of thumb, we always said, whenever you are working with so many things, and then you have to find for the rest of those which you don't know, start with what you know. Like that, start with what you know. So what we know is this 42 degrees right there, lying there looking at us, seeing if we recognize it or not. So when I'm looking at this 42 degrees, I want to see what else is it equal to. I mean, I hope you paused the video by now. I hope you didn't wait for me to tell you to pause the video. Try to solve the questions by your own, and then you'll continue to see if you got them right. So I'm going to start with this one. The 42 degrees, for some reason, it's right there forming a Z formation like that, with this line being parallel to that. I mean, do you see how we symbolize parallel lines? This one, it has 3 stripes. This one has 2 stripes, so they cannot be parallel. But this one has 3 strokes. This one has 3 too, which means these ones are parallel. These ones have 2. This one also has 2, which means these 2 lines are parallel. This one has 1 arrow, and this one has 1 arrow, so which means these 2 lines are parallel. I mean, of course. And then quickly solving this one again, we saw the Z formation, and then now we can agree that this A must be equal to that 42 degrees, right? Of course. So let's put that in writing. I'm going to say A in small letter. You don't put a cap because it's already a small letter symbolizing an angle. A is equals to 42 degrees, We said why? They form a Z formation. Z formation is for what? Alternating angles. Which parallel lines are they using? BA is parallel to FC. Like that, right? And then we found that one out. Let's write it down. Maybe we might need it. Who knows? Maybe we might need to see that this is 42 degrees right there. I mean, from here you can go anywhere. I mean, it's there. They are co-interiors. They are complementaries. Complementary is a nice word. Let's go with it. So here I'm looking at the whole of angle C. Angle C, it's made up of angle A and angle B. So what do I know about that? I know that if I add angle A with angle B, I must get 90 degrees. Because there's a right angle symbol right there. Do we see it? I hope so. Here's a right angle symbol. So angles that add up to 90 degrees, we call them what? Complementary angles. And then you mention your perpendicular lines there. BC is perpendicular to DC. Easy as that, right? So now I have to solve for the unknown. So which means in these two unknowns, one of them is actually known, the other one is not known. So what I know is that I have angle A. How much was angle A? 42 degrees. Plus angle B, it's equals to 90 degrees. And then we are going to say angle B is equals to 90 degrees. And then you transpose this 42 to the other side. Those who understood algebra in term 2. So we have minus 42 degrees there, which is equals to, wait for it, there is someone in the test who won't pull out the calculator. Please don't do that, guys. I mean, as your teacher, if you have found out that you got wrong for just not using a calculator, hey, I don't want to say it here, but my kids know. So the answer is 48 degrees. 48 degrees. Easy as that. So I go to angle B. Let's use a different color so that I don't get them confused. This is 48 degrees. I'm going to say 48 degrees right there. Okay. So now next one, we are left with CDE. Let's go to C. So when I'm looking at C, I mean, it's right there staring at us. I'm sure you all can see it. It's not that tough. I hope so. I have this U shape right there. Here's a U shape. U shape. I know that if I add this angle with this angle, I must get 180 degrees because this line is parallel to that line. What type of angle relationship is that one? Of course, co-interior angles. So here, let's put that in writing. I'm saying, where are we? I'm saying if I add angle A with angle C, I must get 180 degrees. Reason, co-interior angles. Those co-interior angles are using which parallel lines? They are using GF. So here I'll write GF is parallel to another line BC. So I'll say BC right there. I already have A. So A was how much? 42 degrees. 42 degrees plus angle C, it's equals to 180 degrees. This is 180. So, and then simple algebra, we transpose angle C, it's equals to 180 degrees minus 42 degrees. And then here you pull out your machine. Then you're going to say 180 degrees minus 42 degrees. There you get 138. 138 degrees. So I'll just write it down there in case I need it for some reason. So let's say 138 degrees right there. What else can I look for? Let's say D. I see that I have co-interior angles staring at me. So let's use that. Let's use that. Let's use that. Let's use it. Can I erase this? Because this thing of scrolling, it irritates me. I have to scroll up and down several times. As long as I wrote my angles down, I feel like that's enough. Right there. Let's erase this. What do they call that thing? OCD. I think I have that. So yeah, here we go. We are saying we are looking for angle D here. So angle D, again, I know that if I can just take this part and this one and this one, I'll have this U shape like that. With that U shape, I already know that this side is parallel to that side because it's indicated right there. So let's do that. Let's do that. So we just said angle D plus angle B is equals to 180 degrees. Reason, because they form a C or a U shape. When they do that, we call them co-interior angles. Since they're co-interior angles, they need parallel lines. So we have the parallel line EF being parallel to the line DC. And then we don't have D. That's what we are looking for. And then we have angle B. Angle B is how much? 48 degrees. All that is equals to 180 degrees. And then you have angle D, it's equals to 180 degrees. The additive inverse by transposing, it's equals to minus 48 degrees. And all that, you pull out your machine again. Minus 48 degrees. Just to be precise, 132 degrees. 132 degrees. There we go. So I'll just go there to that angle and write 132 degrees. You see what we are doing? Every time we find an angle, we write it there, right? We don't take anything for granted. What if we might need it one day? I don't know. Maybe for some reason at the end of this video or anywhere, we might say, what was this angle? And you need it again. So where were we? Right here. Yeah, we are looking for angle E. So I don't know who doesn't see this, but for anyone who doesn't, for some reason, look at angle C there. I mean angle E. Angle E is surrounded by some nice angles that we already have. I mean, look at that 138 degrees and look at that 132 degrees. I mean, talking about angles surrounding and what would that require from you? Of course, revolution, angles around the point. So I know that if I can add angle C plus angle D plus angle E, I must get how much? 360 degrees. And your reason for that, you're going to say angles around a point. Easy as that. And then we already have the other angles, so no need to worry about that. What is angle C? Angle C is 138 degrees plus angle D, that's what, we have it. We have 132 degrees plus angle E, that's the one we don't have, 360 degrees. And then you add 138 with 132, you pull out your machine right there, you're going to say 138 plus 132 for you to get 270 degrees. 270 degrees plus angle E. Plus angle E. That is equals to 360 degrees, right? And then you solve for E using simple algebra. Minus 270 degrees. And then angle E is equals to, I was going to pull out my calculator again now, but you see this software things, it just malfunctioned and shut down. But then yours won't shut down because yours is not It's not on a computer. So 360 degrees minus 270 degrees, that is 90 degrees. Don't do this. I'm not advising you to pull out an answer from the top of your head. Just use a calculator, guys. Okay. So that is an easy 37 mark question paper I would give you for a class test. And I hope, if ever you were able to watch this video from the start to the end, you paused the video, answered the questions on your own, and then after that you continued to find out whether you were right or wrong about your angle sizes. And then I hope you enjoyed this video. This was not a lesson. This was us solving a question paper together. If you are struggling with these topics, you need to watch the previous videos where we are explaining every detail about alternating angles, corresponding angles, vertically opposite angles, and things like that. So I hope to see you on the next one. For now, we are done for today. This is probably the longest video we have. Enjoy your maths, and I hope you do listen in class. So goodbye.